I'm Julie from the Exploratorium. Welcome to Viral Questions, a series of videos where we answer your questions about COVID and vaccines. A third COVID vaccine has been approved for use in the United States. This new vaccine, produced by Johnson & Johnson, uses a viral vector method of delivery. And today's question is, what is a viral vector vaccine? In our last episode, we talked about mRNA vaccines. That's the strategy used in the first two US approved COVID vaccines. The most important thing to know is that all the vaccines have the same end goal: to train your immune system to recognize the coronavirus without you having to get sick first. So how can we think about the differences? Imagine if you need to give someone some information. You can text them, email, call, or post a letter. There are slight differences to the delivery method, but the end result is that the person receives the information. For any vaccine, the information to give your immune system is a preview of the virus so that it knows what it looks like before it ever encounters the actual virus. Remember that the way the mRNA vaccines do that is to teach your cells to make the spike protein that's on the surface of SARS-CoV-2. They do this by enclosing mRNA instructions in a lipid bubble, and it's taken us decades to figure out how to do that efficiently. But nature has spent millions of years evolving something that is able to deliver genetic information into a cell so that it makes specific proteins. And that thing is actually a virus. There are many different kinds of viruses, but they're all basically genetic material with a protein covering. The protein covering helps them get into cells, and the genetic material tells those cells how to make more viruses. Now, it may seem odd to use a virus to protect you from a virus, but a viral vector vaccine only takes advantage of the virus's ability to get into cells. It utilizes the skill for treatment rather than making more viruses. It's really quite brilliant. The virus used in the new COVID vaccine is called an adenovirus, and in its natural form, some adenoviruses can infect humans and cause colds. Now, the infecting humans part we actually want. Again, we're taking advantage of its ability to deliver genetic instructions into human cells. The causing a cold part is less desirable. We don't want anyone to get sick. Luckily, we can separate these two things. The virus gets into a cell through interactions with its protein covering. Once it's in the cell, its genetic information usually tells that cell to make more viruses. We're able to make viral vectors that keep the protein covering to get into the cell, but customizes the genetic information that tells the cell what to make. In the case of this vaccine, we do not want the cell to make more adenoviruses. We want to teach it how to make coronavirus spike proteins. So to turn a virus into a viral vector, we can swap out the normal adenovirus genome, which is a single strand of DNA, and replace it with DNA that describes how to make spike protein. Just like with the mRNA vaccines, there's no information for how to make the rest of coronavirus, so you cannot get COVID. There's also no information for how to make adenoviruses, so you won't catch a cold either. Vaccinated cells will begin to produce the spike protein, which will trigger your immune system to create the necessary antibodies to protect you from getting sick with coronavirus. The bottom line is that your immune system will start to develop antibodies that fight coronavirus once it's exposed to spike proteins. Ideally, the spike proteins show up as a result of a vaccine rather than part of a live coronavirus. Vaccines have different methods for exposing you to the spike protein, and they're all better than getting that exposure from the virus itself. Please keep sending us your viral questions. Feel free to ask any follow-up questions in the comments, and we'll see you next time.